This is from Lion King. Like Timon, Pamba that says like, have you ever wondered what those sparkly dots are when they're looking at the sky?
Fireflies.
No, like fireflies, and then Pumbaa says like, "Oh gee, I always thought they were balls of gas burning billions of miles away." Like Pumbaa, everything with you is gas.
Yeah, nice one.
So I guess we will wait for a
Yeah,
little
yeah,
bit.
yeah. Wait a few minutes. Usually people
Yeah,
a little bit slow in the morning.
yeah.
Mm-hmm.
Why is it saying like click here on
What do you mean slow? I'm not slow.
What do you slow?
I'm actually in reverse, Brett. Yeah.
If I will mount it out, mount it back.
How do I stop this thing from?
You predictly to return to the video call when you're ready to stop presenting. I don't know. That's fine. That's not.
It's maybe it's because I'm jumping from a tab to the other one.
Yeah, it can be.
I'm gonna shut it out on the Trickster comp, maybe.
Yeah. Right. Hey guys, we are starting.
Oh.
Where was I? I was fixing something here. Ute. Hi, Ute.
Hi, how are you?
Hello.
Good to see you.
Good to hear you.
Here, okay, here. You're right.
Yeah, I don't know how many people in comp will be connected at 9.
Yeah.
Me.
Hey, Michelangelo.
Oh, there's Michelangelo.
Yep. I'll be in the studio in 5 minutes, so I can't see your screen right now, but I'm listening at least.
Well, all in the studio. Like I was like, are you in Berlin or?
Wait, which studio?
No, my studio. Sorry.
Yeah.
Uh-huh.
Oh, let me quickly check one thing. So how many people are in Munich connected right now?
Munich? Only me in Munich. From what I see, I'm the only in Munich. So we have Rodrigo. Where are you? I don't see you in Munich.
No, I'm not in Munich. I'm around Vienna.
Yeah.
Well, but I'm from the Munich team.
Yes.
Yeah, no, it's more of light pollution point of view.
No, this we don't understand this. You will have to explain it.
We have zero pollution because we don't have sky here.
I will explain everything. How far is Starnberg Lake? Starnbergsee, I think it's in German.
Yeah. I don't know. I don't remember how far I was cycling there. Meaning it's not very.
It's not like a 1 hour.
Yeah.
From the city.
Yeah.
Yeah, it's like 16 to 18 kilometers.
Okay.
I'm in Munich too. Yeah.
Then there is Ammersee and Bodensee. Bodensee, I remember because I studied someone that was from there.
Starnberg, it's 40k, even less. If I will see, it's 30 probably.
Yeah, because
35.
you have great skies there.
Okay.
Yeah. Less of the city.
The best one should be in Ober or Unter
Bayern.
Ramengau and
Yeah.
Liederhof. That's the best one.
I was like, skiing.
But it's in the middle of the mountains.
Yep.
Anyway, should we start?
Let's go.
Okay. So thank you everybody for coming. You can all see the thing, yeah?
Yeah.
This is Astrophotography 101, let's say. I will go through some concepts of astronomy first, because you need them to understand it for astrophotography. Um, Nothing too fancy, nothing too scientific. It's just like to know what we're talking about. Then I will go through how the setup works, and then how the whole image processing goes. I can do like a quick demonstration, and then it will be up for questions and like discussion, basically. So, starting with this, exactly before we start, we will go through astronomy core concepts, how to navigate the night sky, so we know like where, how to see and where to see, the differences between celestial bodies, and the difference between like deep sky objects, planetary sun and moon photography, the equipment that we will need, and the softwares and the workflow. So, what is astronomy? Basically, astronomy is a composite word from astron and nomos, which is like star and rule. So, it studies the rule of the sky and of the stars, and we need to know like some concepts before we start looking at the sky. Otherwise, we will not know, and we will not, how to navigate it and how to look for things. Before we start looking at the sky, we need to understand how to move, how it moves, and how we move compared to it. There are two systems when we look at the sky. Let me maybe help you with the stellarium. I don't know if this is showing. No, it's not showing my screen. It's showing just one thing. Sorry. Your entire screen, this one. Condividi. And there we have stellarium. So let me set it up as it was last night. Okay. Fudge. Come on. So you will see, and it's twilight. And now it's night. So this is how we see the sky. And you're like, okay, just, well, without even the planetary names, we look at it and we are like, okay, what's going on? So when we look at the sky, we need to understand there are two ways of looking at it. There are coordinates as we move on Earth. As on Earth, we have longitude and latitude. For moving in the sky, we have the two systems. We have the altitude and azimuth, which is this one. And then we have the equator, which is this one. So what is it? It's there are two systems that we use for navigating the sky, which are systems. The one is based on the person that is looking at the sky. The other one is kind of preset, and like it uses the Earth as reference instead of the viewer. On the PowerPoint, let's go back to it. How do we change there? So the altazimuth, we have the relation is to the observer, and we have the altitude and the azimuth, which is like it's kind of latitude and longitude system, and it's used It's commonly used when you have to refer to a place. For example, for you guys, if I have to give you coordinates for a celestial object in Munich or Berlin, I will not use this. But if you guys are among yourselves, you can use this because it's in relation to you. And then, all right, but I'm not used to Photoshop for the PowerPoint. And then you have the equatorial system, which is like related to the Earth. And this is useful. For example, if I have to give you, okay, you want to look at Andromeda, so it's declination, blah blah blah, and right ascension, blah blah blah, which are the two coordinates, let's say, to that we use. And they're literally like longitude and latitude. You go with degrees using the latitude. So and it's the same. It's like 0 at the equator and 90 at the pole. And then you have hours, minutes, and seconds, sidereal ones, but uh, it's basically like timing instead of degrees. I think it's easier if you see this. So altas, it's like it's in relation of what you see. So you will see like you have 20, for example. Let's focus on let's say Andromeda. So we want to see Andromeda, and if you don't see it, it's this thing. Let me. Okay. So we will see that is 45 by, let's say, 73, like 72 and a half. It's right in the middle. And this is in relation to me and in relation to, well, here says Paris, and the timing, it's 2040. So this is basically like saying, okay, let's see you in the central square at something like the timing, it's like 8-ish. If we want to go for like an accurate location, what we will say is, instead of using the altas, we will say, okay, so now you see the coordinates are slanted because basically we are projecting the equator and the what is it called, the pole, the North Pole and the equator from Earth are projected onto the celestial dome. And now we have like we will say, let's meet at 35 degrees. No, wait, yeah, 42 degrees. And what we see here, it's 2 hours and 1 hour 24 and 9 minutes and 28 seconds. So we will see, like, for an accurate measurement and positioning, you will use this. Any questions so far? Is it like rocket science? Yeah, we called so this is the right ascension. Like the time is the right ascension, and the degrees, like the latitude, is the declination. So you will have the, let me put it where this is the horizon. So this is the right ascension. So in this case, they are slanted because the equator, like the axis of the Earth, is slanted, and the horizon and all the lines that goes above it is the declination. make it make sense. I'll put. Yep. Okay. Well, for without that, it's easier to look for it, like looking at the constellations. So the easiest way is to learn the main constellations. So let's, well, since we can do it. Wait, where is the location?
Guys, I'm just seeing here black screen. How can I see what you're presenting?
You don't see the sky, the constellations?
No, I'm gonna get out
I
and
do
enter
see.
again.
I see it.
Yeah. Okay.
Me too.
I'm not so sure then. Okay. So the easiest way is to learn the main constellations. So, for example, I'm trying to set it up. I don't remember how to set up the location.
So
There you go.
if
So let's say you are in Munich. There. And so this is the night sky in Munich. Well, I don't know if I believe you will see some mountains on the horizon. But how many of you guys can know like the main constellations, like the Small Dipper and the Big Dipper, and maybe Orion? Could be.
I know a few.
I think I can tell a couple of them. Yeah.
Okay.
And I learned that one good guy to start with might be a big star close to the horizon.
Yeah.
And then from then you can have a like a starting point. In this case, I don't know.
Okay. So the easiest way is to like look for the Big Dipper, which is now it's Ursa Major, but like usually it's this guy. It's like 3 dots, and then you have the box, let's call it, and then from this you move up and you have the Small Dipper. It's easier to see like this because they're basically specular. So from the big box you go and you find Polaris. This is Polaris, and then you find the Small Dipper. Otherwise, another one, but it's still not seasoned yet. It's Orion. I think it still has to rise because now it's 2047. So let's move. And if you see some things going around, they're probably satellites or the ISS, which is moving. So because right now in this season, Ursa Major stays close to the horizon, and Ursa Minor, so the Small Dipper, it stays a little bit upper. To find, for example, as Alexei asked, Andromeda, you look for Cassiopeia, which is the big W in the sky, and it's pretty easy to see. Let me take out some of the names. So you see this shape, which is like a big W, and like from this star in the on the bottom, you go for a straight line and you find it. Like if you have a dark sky, you can see like this faint thingy. Otherwise, you will need something like an eyepiece or a telescope to with a camera to see it, because it's faint. And yeah, any questions?
quick question. You talked about the 2 coordinate systems.
Yep.
One is the azimuth and
And the other one is the equatorial one.
Yeah. So the equatorial one obviously is stationary.
Yep.
It always stays. So the same coordinates are the same
Yeah.
everywhere in the world.
Exactly.
The other one is
It's based
it's
on the
based
local
on where I
position.
am. So
Yeah.
you need to know. So you need to know where I am to know
Exactly.
where I'm looking at.
Think it's not very correct to say, but think of it like, for example, if I am visiting Berlin or Munich, like if I have to come to the office and I'm here, like in Italy, and I will look on Google Maps and it will say it's like I don't know, Schlesische Straße, or the other one I don't remember the address. It's Maria something. Anyway, and that's like the correct address. Meanwhile, if I am on the road there, they will say like, oh, it's 5 blocks from here, like turn left, turn right.
Yeah,
That's basically like it.
cool.
Then I've lost the controls. Okay, so celestial bodies: stars, planets, satellites, comets, asteroids, meteors, and meteorites, which they are not the same, nebulae, and galaxies. So these are the main bodies that we see in the sky. There are a few differences between them. Probably you all know them. I did like a very comprehensive thing. So we have stars, which are those fireflies that got stuck to that bluish thing. No, so they are mainly like giant masses of gas burning thousands of degrees, like Kelvin, in like millions of kilometers away. And we have a way to classify them. There is this OBAFGKM. There is a like a saying like, "Oh, be a fine girl, guy, kiss me," to remember it. From the hottest, which is O, which is the coldest in temperature, to M, which is the coldest in and coldest slash hottest in Kelvin temperature, and it's in visibility. Usually, the G class is the most visible, like what we see around the sky. It's the most present, but there are several other scattered here and there. So when you see like, for example, let's say Sirius is one of the closest to us, and if I'm not wrong, it's an A class. So it's hotter and it's bigger than the sun. Our sun, it's a G class, and it's not that hot and not that big. It's a kind of like yeah, it's an okay star. We measured the visibility of of the stars in magnitude. Like the less it is, the brighter we see it. So, for example, it's the sun is -27, I think. Um, well, when it's seen, or -47, I don't remember. Uh, so when you look at a star chart, and there is a lot of light pollution in your area, like look for the uh, lower number. So this is what you can see. For example, when there was the comet Neowise, it was like -50 or something like that. It was like crazy amount. Then there is planets and satellites, which we all know them, except for one, which is no more with us in the chart, Pluto. So there are astronomical bodies orbiting a star or a stellar remnant. So, for example, if it's brown dwarf or a yellow dwarf or a white dwarf or whatever, They're massive enough to be rounded by their own gravity, but not enough to ignite thermonuclear fusion. For example, fun fact, if Jupiter was like this tiny amount bigger, we would have two suns, because Jupiter is like on the line of being a star, but it's not yet not big and not hot enough. They can be classified as terrestrial or gas giant. Usually, we have on the how based on how solar systems form. We have near the main star terrestrial objects, and on the outskirts we have gas giants, because of how gravity works and how planets form. I'm not going to delve into it. Um, and then we have satellites, which are bodies orbiting a planet, often referred as moons, but the only moon is the one orbiting Earth. The other ones are all satellites. The famous one that we can all see with a naked eye is Moon, almost every night, except when it's new. And the other ones, the first ones that were discovered are the Galilean satellites from Jupiter, which they can be seen with a binocular, like with a very simple eyepiece, and you will see like Jupiter with four dots. And then there is a quote like, "That's no moon, that's a space station." 10 points to whoever gets it. Then comets. This is on in the background is Neowise. Comets are icy, small bodies that, when pass near stellar bodies, they begin releasing gases, producing the iconic tail. So they're basically huge chunk of ice and other stuff. They come from outer space, outer space, from our solar system. They usually have a really big elliptical orbit, and this brings them close to the main star. They start release like spewing out gases and oxygen, because there's a lot of water in them, and they either continue on their trail and they go out and then come back in like years or centuries. Otherwise, they just smash into the sun or they dissolve, because they pass too like near, and we don't see them anymore. Meteors and meteorites. So the main the main naming is like shooting star or falling star, and a lot of people like confuse them. So basically, the thing is, it's a meteor when you see it, and it's a meteorite when you can touch it. An asteroid, if you see it, like, okay, it's too late. um, you probably saw like a meteorite even when you go like in the mountains or whatever. You probably saw a piece, because they are literally everywhere. Um, so the meteor is what you see on like St. Lawrence night, or when the November shooting stars. They're actually like next week. So go out if it's not too cold. And it's basically like when they burn up in the atmosphere, that's a meteor, or a bolide. For example, I don't know why, but like a lot of people in Russia get them. And one of the most famous one, it was like what, 5 years ago, 6 years ago, and you could see like this huge thing traversing the sky, and it exploded, and well, it didn't kill anyone, but it did a loud bang.
I think
And
they have a lot of them in Russia because they have a lot of dash cams.
yeah. And then meteorites are basically meteors that survive the atmosphere, so they don't burn up completely and they don't get smashed when they hit the ground. And you can see them because let me bring up my meteorite. You can see them because they're bubbly. Let's say meteorite. There we have it. Can you see it? Yeah. So this structure that we see, it's basically like the burning of the atmosphere, like bubbling it up, and they're like present throughout, and they're usually like um, iron based. So the red color. Yeah, so you probably came across them. Then mm, 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 mm. Where is the controlling thing? Nebulae and galaxies, what we are looking for basically. So nebulae are these huge, like literally light years big clouds, and they're mainly like hydrogen, helium, and oxygen. And then you could have other stuff. They could be there could be literally anything in them, especially if they're like remnants from supernova. Then you could find gold, you could find like whatever element on the periodic table, and you can have it. There are five major groups. There is dark, emission, diffuse, planetary, and supernova remnant. They are distinct, and you can basically catch it like that. For example, we will see some examples. I can bring them up here. So, for example, the Crab Nebula, which is this one. This one is a supernova. So you can basically see like this explosion pattern. Um, so we see like the huge what is it called, the wave, and these bits which are the star that exploded. Or for example, we have the most photographed as a beginner target. It's the Orion Nebula, which is not here. Let me get rid of the horizon so we can see everything. This is the Orion Nebula. This is an emissive one. Then we have, for example, the Horsehead. Moon is up in a few days, and if you try, you will see that when you start like zooming in onto the moon, you will see some bubbling, and that's our lovely atmosphere. So when you start shooting at the moon, you will see this, and if that is problematic, imagine shooting something that it's like way farther. So for example, when you shoot Saturn, you will think you will get like this amazing shot, and then you get like a bubbly mess. And planetary imaging usually doesn't rely on single shots, but rather you shoot a video and then you merge the frames together in order to get like a nicer image. Then you have sun imaging, which is very interesting. You get you can get to see like the structure of the sun. Um, how is it done? It's done through like a sun sheet. It's called. It looks like tinfoil basically that you put on the lens that will cover mostly I think it's like 98% of the light that is coming through, and you can see like the granular surface or the sunspots, or like use it for other kind of things. Let me bring it up. Let's see. Sun photography. So this is what you can see. Like for example, this is like an example, or if you're really into it, you can get like sun flares and like coronal mass ejections and all these things, which are amazing, and they show you the sun from another point of view and not like the very bright thing in the sky. Then we have the moon imaging, which is the taking pictures of the moon, and you can focus on, I don't know, like a crater or like the whole thing, and just like usual pictures of it. So far, so good.
Yep.
Nice.
Yes.
Fundamentals. What you need. Dark sky and a still sky. So how do you the dark sky, we will get into it. The still sky is the 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 most important thing, because like when you do this kind of photography, you need like minutes, if not hours, of exposures. So you don't want the usual like cool effect of the star trailing, because the apparent movement of the sky, because of the Earth rotates. So the dark sky, it's really easy. You can go, you travel far away. Europe, not really fun, because you have to travel like, you don't have to travel a lot, but you have to basically find where to go. US, for example, they're amazing. You just go into the middle of the desert and you're done. And the conditions there are amazing. For example, if you go in Death Valley or like the Sonora Desert, those are amazing. You don't have dew, everything is like super dry, so you don't have to worry about like fogging up of the lens and other stuff. The still sky can be achieved with the sky tracker, which is basically I don't have it right here. I will show it after. It's basically a tiny it's a mount which rotates very slowly, and so it rotates in synchronous to the sky, so you basically have the still sky, and we can see one in the background, and then there is like the one that I mentioned, the light pollution, the amazing thing from man. Um, for this, there are a few ways that we can fight it. Like it's through filters or through traveling. Like if you can't travel anywhere, uh, these filters help big way. Like here you have a before and after. And they basically work by allowing only certain wavelengths go through the sensor, and or through the lens. It depends where you apply it. And there can be like two kinds. One, it goes onto the sensor, and the other one goes onto the lens. One note: you can use them on camera, like Astro cameras or normal cameras. The only difference is that an Astro camera doesn't have the IR cap filter, which is the one that it's basically put everywhere, and we love IR informations. And here, for example, you have like the classification of some example of classes of sky. So bottom class 5, it's pretty much anywhere. Then this is like a very this could be the outskirts of Munich or Berlin. Bottom class 4 is like Black Forest. No, it's like let's say 50, 70 kilometers away. And then Border Class 3, that's like Black Forest or like literally middle of nowhere. And this is the example of the cutting of the filter. So you have like when this goes up, it's shown, so it's allowed to pass through, and then when it goes down, it's blocked. And what basically these things do is blocking the sodium vapor length and all like the light from the city. So this orange halo, which unfortunately it's going away because they're being replaced with LEDs, and LEDs are nightmares because they do not have a specific length, but they cover all of the spectrum, so you basically can't filter it out. So the instruments that we use, this of course it's from an amatorial point of view. It's a very sturdy tripod. You don't want anything wobbling or like not supporting all your expensive things. This is the main piece, and it's the thingy that rotates, the star tracker. A ball head, which is used to orientate the camera. So you basically, this goes to the north. This is always pointing the North Star because it's the only star that stays there and it doesn't like move. And then you have the ball head if you have to point in it to like whichever object you want to photograph. A DSLR, if it's a full frame, it's better because it captures more information. Even you can do it even with a micro four thirds. Um, and then a lens. Lens can be like from 15 millimeters to like a telescope. I Munich. Let's say we want to shoot Andromeda, and we check where is it in the sky actually. So here we see it, and we say, okay, it's right around here. So it's an amazing spot because it's right up. We don't have to shoot through any. One thing: if your target is straight up, it's better than like on the horizon because you have like layers of dust, pollution, and light pollution. Meanwhile, when it's pointed straight up, you have less stuff to go through. So what we see is like where the guy is. So this is here, amazing, and then we have this amazing thing in Stellarium. By the way, this is a free app. we can set like the sensor with the lens and like to see how it will be framed. Oh fuck! And on this one, I don't have the setups because this is another user. Sorry. G. Anyway, sorry. Because on my user, there are my cameras installed. On this one, you basically can see how it will be framed, so you can even start framing it before you go outside and see how it will look like on the camera. Then we have the light pollution map that we need to check. For example, I was checking in Munich. So like here we see there's like tons of it. Usually what you want to look for is blue. Unfortunately, we see that Europe is not that lucky. So what we do is just going for a slight green or even yellow. We are happy with it. And around here, for example, the best place is, it will be like in the Alps. Since we don't want to travel that far, these places are okay, like yellow, green. It's super nice. Here it's doable with like a lot of love imposed. Then we have windy, because light pollution is one enemy, but we don't wanna like go for sorry for the Italians, it goes on automatic. We want to check how the wind is, how the dew point. Why is it showing in Italian? I don't know how to change. English. Well, for example, we check the weather with first with the radar, and then like with the satellite to see if there, well, yeah, there is stuff coming, and then we check the cloud base cover and see if there is anything that can be seen. Sorry, there we go. Then this is a stellarium that I was saying, like you can frame it here. You can see like my 60DA, and here's the one of the eyepieces that I use. This is a 500 telephoto lens, and here shows how it will look on my camera. This is the sky tracker. So it's a tiny thing, and basically you mount the declination arm on this thing, and it will rotate with the sky. What you do is through this eyepiece, or in this case, it's in behind this cap. You will look for the North Star, and then using an app, you will frame it in a certain way in order to like stop the rotation of the sky. And this is basically how to polar align, so you don't get that nasty background, which is basically why this is built for. How to focus for a star. There are two ways. The first one, the easiest one, is to put it out of focus. So you blow out the star, and then you go all the way on the end of the focus ring, so it blows out again, and then you find the sweet spot where when it gets pinpoint. Otherwise, you will get a bad enough mask, which is this like stripy thing that will give you the diffraction, this diffraction pattern on the star. Of course, then you will remove it. And like if it's on the left, it's inside. If it's on the right, it's on the outside. And if it's in the middle, like on this cross, you will get this thing going back, left and right. That will give you like the most accurate focus ever. Then you will actually start taking pictures. These pictures are called light frames, and they range from like 30 seconds to 30 minutes, whatever you're looking for and how much details you want to keep from in them. And then like you will stack them for the to have the final product, which is the then referred in hours of exposure. I'm running now because I saw the time. And then what we do is shooting calibration frames, which are these amazing things that allow you to remove the noise from the image without sacrificing any details. What you do is you shoot whatever you're shooting, and then you cover the camera. And since the sensor is affected by the temperature, you will shoot what they're called the dark frames and the bias frames. The dark frames are used to create the noise profile instead of going through neat video. And so you shoot a lot of frames with the same settings, so long exposure and like I don't know, you put 45 seconds, you will shoot like 20, 50 frames with a 45 seconds exposure, and that will give you like the overall noise that's on the camera sensors
with a cap on.
Yeah, with a cap on it. So you will have full dark thing, and then you will switch to like the lowest shutter speed possible, always with a cap on it, and you will shoot the bias frame, and that will give you the. Do you know that when you expose up on Nuke, you will get all of those bars and weird stuff that you see? That's the dark noise on the camera sensor. And that basically gives you a ghost, and you can remove it when you're processing the pictures. Then you have the flat frames, which are used to take out like any dust, dirt on the lens and the vignetting. What you do is either like put a shirt on the lens and shoot at the sky, like during daylight, or you can shoot like a white illuminated thing. For example, I usually shoot my screen, like I put notepad and then shoot it, and then we'll give you like a good profile. Then what we use as a software, it's called Deep Sky Stacker, which I will bring up in a minute. So just a second. So for example, I will use this. So this is a picture like straight out of the camera. So you will see like this red tint. These are exercise files that I will share with you guys, so you can practice if you want. And they are like this tint because of the filters. So don't worry. What we do, these are 8 minutes exposures, so pretty good. You shove them in here. You tell him like these are light frames. Then what you do, I have the bias, and you tell him these are bias frames, and these are like the dark ones. Then you tell him these are dark frames, and that's it. Yeah, I have only these. What you do is like, well, you first have to check for them. You have to look at them, and if you have any plane passing through, any ISS satellites and stuff. Now, thanks to Elon Musk, we have these lovely trails of dots of those satellites. So thank you. And so you have to remove them, otherwise the stacking software will get crazy and won't align the pictures. You check them, and then you stack them. These are like settings. It even goes like for recommended settings. So it's a very babysitting software. You can delve into it and you can play around with a various method that he uses. You can see here that this is a total of 1 hour and 4 minutes exposure. You tell him to stack them, and he's gonna do his thing. Then you move when you after Deep Sky Stacker is done, you can move on to Photoshop, GIMP. What is the other one? Affinity, even Nuke. You can save out like a TIFF, so and it's a 16-bit, so you can probably try using Nuke. I've never tried it, to be honest. And that's it. I'm gonna quickly show you how the thing works, since it's pretty fast. And if there are any questions so far. Too fast? Oh, shoot. Well, here I have the other one. So this is a picture of Andromeda. So this is the base one coming out from Deep Sky Stacker. Then you have the denoise. Why do I have this thing that it's okay? And this is the correction. So and it's quite easy. Like for example, for the curves, you can play around and bring out details and whatnot. And then there is like a collection of tools which I don't have on this user, and they're basically a set of action that are specifically designed for this kind of photography. Let me, yeah, here it's done. So it's washed out and all of it. And here you see this thing. This is an airplane. No, yeah, double streak. It's an airplane. So you will have to take them out, either painting them or like remove the affected frame. But if you guys want, I can give you the either if you want the whole like stack of pictures, or if you want the final one like this one, and you want to play around with the colors. Yep. Okay, nice. Cool. Hope this wasn't boring. I hope this was like not too strange.
Was interesting, man. Thanks.
No, it was great. Very informative. Thank you.
Thank you very much.
Yeah, thank you, Ale.
Cool. Thank you guys. And see you in a bit.
Bye.
See you in the dailies. Bye bye.
Bye.
Take care, guys. Take care.